So did you get to finally have a sound appointment Tom for this afternoon? Yeah, you suggested that we met at your hotel.
Yeah, he didn't like that idea because it's rush hour and also he's suggesting as an alternative that we meet for what I call lunch.
Yeah.
Tomorrow.
Okay.
He says that'd be and we could meet somewhere convenient
Yeah.
for all of us, and that would be a little easier for him to get to that. So you and I are supposed to sort out where we want to meet him on today, and then I can let him know.
Yeah.
Call him. We just need it to restaurant. But it would be nice to see it.
Yeah, sure. It's always interesting to meet him. You end up with a head full of ideas, and perhaps too many. That's always interesting.
Have to sort out which ones to put in.
Sí.
But yeah, Tom and I worked together on this economic geology special mission years ago, and so I got to
I remember.
men. Yeah, do something. Been friends since we haven't had much chance to work together. We bump into each other rather than occasionally.
Yeah. So you're currently based where?
In Colorado.
Colorado.
I've been working full time in the Caribbean region since '87.
Yeah.
But lived for a while. 3 years in Costa Rica, another 3 in Panama, another 3 in Vancouver.
Yeah. Hola. Buenos días. ¿Qué tal?
Aquí traigo la...
Perfecto. Sí, la pequeña Biblia. Sí, eso voy a necesitar.
Me voy a cortarlo a la mitad.
Es un poco larga.
No.
Y bueno, si también no se falta esto, pero...
No, los resúmenes de las conferencias no serán necesarios. Ya lo explicaron.
Ya lo explicaron.
Simplemente.
Por cierto, doctor, ¿quiere que le demos la constancia al final de las dos conferencias o una cada conferencia? Yo creo que ahorita podemos hacer.
Si la tienen lista, pues...
¿De una vez? Ok. Entonces,
Si no, pues no.
¿no hay problema?
No hay problema.
Entonces, bueno, voy a traer a los estudiantes que invité.
Sí.
Voy a apostarles a...
Sí, a pastorearlos, porque ya casi.
Hola.
My wife, María.
Hola, nice to meet you. Voy a rechazar la música que tengo.
Sí, salieron.
Que me pongan, necesito que me pongan en internet.
Todavía no. Mejor dile a Alejandro.
Sí.
Porque los otros. So, let's see what we can hold on. Hola, están tus cosas en la ¿tú? Están tus cosas en el coso. Ah, creo que ya andabas practicando un cadáver de metí el auto al estacionamiento. Pues está bien. ¿Traes tu auto? ¿Tú traes tu auto? No. No, porque no. Sí. Sí, sí. Bueno, los que no vengan del curso les puedo poner.
Ese comunicado también.
Ah, claro, sí, verdad. Yeah, because I'm currently teaching this semester all waterfalls and all geology. And I told them that all the students that are not showing up to it's the end of the semester, so everyone is pretty doing other things. And here's someone you need to meet. Maricela.
Maricela, mucho gusto.
Maricela is currently doing master's degree in doing geology and metallogenic mapping from southwestern Mexico, which is going to escalate to the whole map of the republic. Once she's completed her master's degree and started so she's the one who needs the most and she's going to be trying to collaborate in order to joint efforts with the Mexican Geological Service, because she's from the Mexican Geological Service. So we need all the geological base they have, the base geological maps and all the data they have by using or not using at all. She's the liaison person.
You're going to be here for a while.
That's it. Yeah. Let's see how it goes. And we start with just a small piece and then go well.
Sí, entiendo. Sí.
They need to get used to English language. They really do that.
I will do it in English. It's more helpful.
Well, I don't know if it's much helpful, but they really need to get in touch with someone who speaks English and learn from that, because they are too used to have things, to get things the easy way. So I think they are going to benefit from making an extra effort. So unless they have any doubt about something they really don't understand, then you might change to Spanish or start with English only.
Good. Okay. And for our discussion later as well.
But they need to practice. You too. And it's easy when you only have to the difficult part of this is when you have to speak. Writing is okay. Listening is easy, but speaking is hard. It's always hard. Try. Pushing yourself forward. So, some of
No, porque tenía como mis aplicaciones todos estos o casi más lo bloqueé desde el Excel, lo bloqueé desde no puedo salir sí,
Bueno, pues buenos días, muchas gracias por venir, espero que lleguen más, de todos modos ya podemos seguir empezando. Hoy y mañana hay otra plática a las 10 de Tao. Es un placer contar con Carl Nelson el día de hoy y mañana para contarle un poco de la metallogenia del Caribe, ¿no? Que es una zona, supongo que saben, adyacente a nuestro medio geológico. A veces no tiene sentido, pero y además él es el editor invitado, el coeditor invitado de una publicación muy importante para la geología de yacimientos minerales de México, una publicación especial de la Society of Economic Geology del año 2001, ¿sí? Junto con Tom Alvinson. Esperaría que hubieran escuchado ya hablar de ella, si no, corran a la biblioteca y lean un poco, porque es una publicación, digamos, de orden mayor para los que nos interesa trabajar en la geología de yacimientos minerales en este entorno. Bueno, Carl se graduó en el Antlers College en 1973 y obtuvo su grado de maestría en 1975 en el Dartmouth College en Estados Unidos también. Desde entonces ha estado pues un poco a caballo entre la empresa y la academia en diferentes lugares, más en la empresa que en la academia, en empresas como Anaconda Copper Company, trabajando en Homestake, en la región del Caribe, la Universidad de Costa Rica, en muy diversas empresas y en concreto, además de muchas otras minas y prospectos mineros, ha estado trabajando en un yacimiento que seguro les suena si han trabajado en epitermales, que es Pueblo Viejo, en la República Dominicana, que va a ser el objeto de la plática de mañana. Entonces, es un poco de esas raras personalidades, ¿no? Que está a caballo entre la empresa y la investigación pura o la academia, y pues eso les puede servir mucho a ustedes, digamos, a los estudiantes particularmente, con carrera en sus inicios. Tanto se pueden, si quieren ir hacia un lado, hacia el otro, o como mínimo, pues tratar de aprender de alguien que está casi permanentemente con un pie en cada lado. Entonces, espero que les resulte muy, muy provechoso y ponga mucha atención. Y sin más dilación, pues los dejo con Carlos.
Bueno, muchas gracias, Tony, y gracias a ustedes por participar hoy. Yo voy a hacer la charla en inglés, pero voy a hablar despacio y si hay alguna pregunta, con mucho gusto podemos hablar y tratar de explicar un poco más.
Two pointers. I don't know which one is going to work better.
As you just heard, I've always really, right from the beginning, had a foot in academia and a foot in exploration. So most of my experience has been as an exploration geologist, but the basic interest that got me into geology and exploration geology, and I'm sure that I share with you as well, the basic interest that brings us all to geology is to understand better Earth processes. So we're going to be talking about the tectonic evolution of the northern margin of the Caribbean plate today, the Greater Antilles, and trying to figure out, first of all, what that tectonic evolution consists of, and then how it relates to the metallogenic evolution. And I should mention this talk this morning is really a way of introducing myself to all of you. The reason I'm here is to work with your group that's active with the metallogenic map of Mexico project, to share some of my experience trying to assemble a metallogenic map, in this case of the Greater Antilles, and to share also some of the compilation work that I've done on Mexico so far. So we'll talk this morning about the Greater Antilles in general, and then tomorrow we're going to focus a bit more on a single deposit, the most important gold deposit of the region, which is Puerto Viejo. So here's, we'll start with the final slide. Here's the metallogenic map of Mexico. Unfortunately, maps don't project very well, as I'm sure you've all found out, so I brought a printed version here that we can look at in more detail during my visit today and tomorrow. What's printed on top there, all the dots of various colors, are the mineral occurrences. The deposit types are shown according to shapes. The commodity according to color, so yellow is gold and silver, as you might expect. And then the sizes according to the gross contained metal value. And to summarize briefly, the most value in terms of metallic minerals in the Caribbean come from the aluminum deposits on Jamaica. $817 billion in gross contained metal value. Now, of course, that's not what they're worth, because it costs money to extract that material, it costs money to build the plants, that sort of thing. But if you just take the amount of aluminum in the ground and the amount of aluminum produced over the years and multiply it by a current price, that's the figure you get. So in a general way, it gives us an idea of where the greatest value is in the metallic resources of the Greater Antilles. In second place come the nickel, cobalt, and chromium deposits. Third place are the gold and silver deposits. And finally, we have the base metals. Most of that gold-silver resource comes from the Pueblo Viejo district. Pueblo Viejo all by itself is 30 million ounces of gold. And the location of Pueblo Viejo is here in the Dominican Republic. Well, metallogeny, how do we approach that? We'll have to start with geologic maps, and in the Caribbean, I'm dealing with a mosaic of geologic maps. I'm sure you've run into the problem of taking maps from adjacent quadrantals and finding that they don't quite match across the boundaries sometimes. Well, you can imagine at the country scale, maps that have been published back as far as the 1970s and as recently as 2010. So what we really have when we look at a geologic base map for the Greater Antilles is a geologic mosaic. Similarly for the legends, and that, I know you can't read that legend, but that's exactly the point I want to make. There are just too many rock units for anyone, a local expert in any given country to understand what the significance of those rock units might be. Cuba, for instance, maybe reflecting the Russian influence in their tendency to over-divide everything, has 237 rock units all by itself. Here's the most recent published map of from the region from 2010. There's now a published geologic map of the Dominican Republic. But again, the legend doesn't really help us as much as it could in terms of understanding the tectonic setting of these rock units, and understanding the tectonic setting, beginning to understand how the metal deposits fit into that evolution. So here we have on a single country 1, 2, 3, 4, 5, 6, 7, 8, 9 separate legends, all for different parts of the Dominican Republic. And of course there are valid reasons for doing this. You don't want to project rock units across major tectonic boundaries, and we have a lot of those in the Caribbean region. But it does impede our ability to understand. That's one issue. The other issue is that rock names are typically named for local areas, like, for instance, the Duarte basalt. So people outside of the Dominican Republic don't understand what that might mean. What kind of basalt is it? Is it an island arc basalt? Is it oceanic plateau basalt? Is it a back arc basin basalt? We really don't know. Well, this fellow, Manuel of Cuba, probably the most prolific author in Cuba. He's the author of literally hundreds of papers. Started out as a paleontologist. He helped us out, and he took out, in 1998, he took those 237 rock units from the Cuba geologic map, and he reduced it to 4 or 5 colors. So this then gives anyone, just at first glance, a very clear understanding of what Cuba is geologically. We have the margin of the North American continent in blue here. We have the northern ophiolites in purple. So that's an old subduction zone and fragments of oceanic lithosphere that rode up on the continent in the North American margin. Then we have a volcanic arc, an interoceanic arc that formed out in the ocean and eventually collided with the continent along this ophiolite belt. And we have the Yucatan borderland, which are largely rift-related terrestrial and marine sediments that were formed when Pangea began to separate. So I think this fellow did us a real favor for geologists in general, and in particular for those of us who are interested in metallogeny, because now we can look capture very quickly an understanding of the tectonic setting of the Cuban rock units. That inspired a lot of folks to come along afterwards, and this group has been working now for many years on understanding the details of that tectonic evolution, particularly of those ophiolites, because in Cuba and also eastward along the Greater Antilles, that subduction zone is ridden up on the North American continent, and it has exposed the high pressure at the actual subduction channel with its high pressure blocks, and that's been a fertile area for investigation. So let's start pre-Caribbean. Here's the Pangean supercontinent. So we don't even have a Caribbean region yet. And we'll work through the tectonic evolution, the construction of a tectonostratigraphic map, and try to fit the ore deposits into the story. Now, those of you who are working on the Mexico map, you can be thinking, while we go through this, what are the appropriate divisions to make in a tectonostratigraphic interpretation of Mexico? Because after all, I'm sure you face the same situation of abundant rock units, local names, and lithologic descriptions that don't always tell us what the tectonic setting might be. So I've started here with the North American continent and its Mesozoic passive margin. So this, in a sense, is a single rock unit. A little bit of continental crust still exposed in northwestern Cuba, but basically we're looking at the passive margin of North America, and occasionally at fragments of that passive margin that have been subducted. And here then is the distribution of those passive margin sediments across the Greater Antilles. In the late Jurassic, we begin the history of the tectonic history of the Caribbean with the separation of North and South America, really an extension of the spreading between North America and Africa. And we begin to generate rift basins. And with the generation of rift basins, we also begin to get mineralization. So right from the beginning of the tectonic history of the Caribbean, we're generating metallic mineral deposits. Here now I've added the rift-related terrestrial sedimentary rocks, and they're mostly in the western part of Cuba. Whenever you see a little white box like this, that means that the next slide is going to zoom in and focus on that particular area. And what we have in western Cuba, largely hosted by these rift basin sediments, are sedimentary exhalative and sediment-hosted massive sulfide deposits. In total, about almost 1.5 million ounces of gold, 55 million ounces of silver, copper, lead, and zinc. NZX deposits, as I'm sure you've been studying, relate to rifted environments where you have deep fluid circulation and deposition either at the sediment ocean interface or replacements, the so-called MVT type on incarbonate reef environments. As an example, the principal example is the noviembre deposit in Cuba, which produced 500,000 tons of copper and still has a remaining resource at an average rate of something like 4%. Stepping a little bit younger now, early Cretaceous time, we continue to separate North and South America, and we're generating new oceanic crust as the two continents separate one from the other. So we have two types of oceanic lithosphere. We have the so-called Proto-Caribbean oceanic crust forming between the continents, and we also have Pacific oceanic crust being subducted off the west coast of the Americas. So now I'm going to add another rock unit
which has a few colors, but basically we're looking at fragments of Jurassic and Cretaceous oceanic lithosphere. And to help us understand tectonic evolution, rather than paint them all in one color, I'm painting the ones of Pacific origin with this lavender color, the ones of Proto-Caribbean origin in blue, and then here the supersubduction zone, ultramafic rocks, and finally the exposures of the actual subduction channel with their high pressure blocks. So we can actually distinguish, based on the detailed investigations and various doctoral dissertations, whether we're looking at an ultramafic rock that formed beneath the Pacific Ocean floor, one that formed beneath the Proto-Caribbean Ocean floor, or one that's part of that, the mantle wedge. And one of these mantle wedge ultramafics that rode up as it collided with North America is where we find all of the famous nickel-cobalt lateritic deposits of eastern Cuba, and also the chromite deposits. So this is by far the most important metal district in Cuba. Not over 9 million tons of nickel in terms of past production and current resources. Moa Bay all by itself has produced over 700,000 tons of nickel and has resources of 47 million tons, grading a little bit over a percent nickel and 0.13% cobalt. Here's just a look at the cobalt mineralization. I put the formulas up there more as a reminder for me because I can't remember them. But they typically is cobalt-bearing manganese oxides that form at about this location in the weathering profile. We should mention the chromites as well. We've got potiform chromites, the largest in all of the Americas at the Mercedita prospect in Cuba, and they form in that mantle wedge. And there's Mercedita, a photo of the deposit itself, with a 5 million ton resource averaging something like 24% chromium. The lateritic nickel deposits are the most famous. Here's an example of one from the Dominican Republic. Here's the typical lateritic weathering profile, and although the numbers are hard to read here, you can see that most of the nickel is in this yellow limonite to transition and saprolite zone. I've started adding figures now and then to emphasize the benefits that these projects bring. They're undeniable in terms of the money they generate and contribute to the local economies, but it's definitely true that income can vary quite a bit from one year to the next. So here's what was sold by the nickel mining company there in the Dominican Republic according to year. These are hundreds of millions of dollars in receipts, in gross receipts. And then here's what's paid in taxes from one year to the next to the Dominican Republic by that mining operation. So you can see, although the numbers can be substantial, that's $200 million there. Some years the government doesn't receive anything. Others it might receive $200 or $300 million in tax receipts. So it can be an important source of income, but it's not a very reliable one. So now we're going to move into the island arc part of the story. In the early Cretaceous, we have the onset of island arc volcanism, an intraoceanic island arc, which, according to Paul Mann's model, was forming in the Pacific, well to the west of the island arc that existed along the western margin of Pangaea for so long. Here's a different model, Tyndall's model for the Caribbean evolution. He doesn't see an arc out here to the west. He sees it all developing in close to the margin of the Americas, and the Caribbean island arc developing, beginning as an inter-American transform fault. And then we begin subduction. We begin to subduct that Proto-Caribbean crust in the early Cretaceous, about 130 million years. So that debate is still unresolved. But in terms of its relation to mineralization, to metallic mineral deposits, what we begin to see with the development of island arc volcanism, those chromium-rich chromatite deposits are beginning to form, and we're getting bimodal mafic volcanogenic massive sulfide deposits forming in the very early island arc. So here's our typical volcanogenic massive sulfide deposit schematic. I'm sure you've all seen pictures of the actual videos of them forming on the seafloor. I think the first one was discovered back in the early 70s, and there are literally hundreds of known active volcanogenic massive sulfide vents on the seafloor today. Some photos of those so-called black smokers. It's really a suspension of sulfide that's pouring out of those smokestacks. So where then do we look for VMS deposits, the sorts of things that might form early in the evolution of an island arc? So I've again taken that mosaic that you remember of all the different geologic maps. Here's where the tholeiitic island arc volcanic rocks are across the Greater Antilles. So that's going to be our playground for volcanogenic massive sulfide deposits. We're going to look at this area here in the Dominican Republic, where we see a cluster of volcanogenic massive sulfide deposits shown in blue here, one of which is in production, Cerro de Maimon. And it's not far away from this famous Pueblo Viejo gold-silver district. One of Joaquin's students, I think, spent some time here with you folks, Lizard. I know a few of you have met him, and he's now, having studied the Cerro de Maimon, he's proposing that form very early in the island arc evolution in a 4-arc basin. A lot of the compositions we're seeing in these rocks are bonanitic in composition. Tholeiites, but bonanite composition. So here's Cerro de Maimon, close to 5 million tons, averaging 2.5% copper. And also we have some back arc basin examples as well. Back arc basin volcanic rocks in western Cuba, and Júcaro, one of the examples there that's produced 62 million tons. I know there are a lot of details in terms of reserves and resources here, but that's all in the paper that was quoted at the beginning of the article, and I'm happy to provide you with a copy of that as well. So that tholeiitic island arc that began, some people put it back as far as 130 million years. It was interrupted the island arc volcanism was interrupted by a period of extension across the arc at about 110 to 118 million years. And that's based on Escudo Veduete's work on this back arc basin here. He dated back arc basin basalts that were formed behind that Tholiitic arc. And it was that period of extension that turns out to correlate with the period of time when Pueblo Viejo was deposited. So Pueblo Viejo is located right here, kind of in the middle of that volcanogenic massive sulfide district. This is a geologic map. I've had the opportunity to map in the pits for over a period of several years at 1,000 and 1 to 1,000 scale and 1 to 2,000 scale, so I walked every bench. This is a simplification or a condensation of that geologic mapping. Basically, we have a few major rock units. The basaltic andesites, which you can think of as that Tholiitic island arc. Some dacite porphyry volcanic domes that formed during that period of extension. And then an epiclastic sedimentary basin that's also part of the Tholiitic island arc and has been overridden by a reefal limestone that represents a fringing reef, if you will, around that early Cretaceous interoceanic island arc. These are outlines of the pits of Pueblo Viejo. It really is a monster. 5 million ounces of production through 1999. It produced from the oxidized portion of the deposit. In this case, the oxidation is all a product of weathering, and you can still see remnants of that oxide cap. But once they got into the sulfide prodor underneath, this black sulfidic carbonaceous stuff, the recoveries just dropped off and the mine wasn't able to continue to operation. Nonetheless, there was a huge remaining gold resource in that sulfidic prodor, almost 300 million tons at close to 3 grams per ton gold in an open pit environment. The problem is that it had every single metallurgical problem known to the gold recovery business. It had high sulfide concentration, so the gold would be encapsulated by sulfide. There was silicification, so the gold was encapsulated not only by sulfide, but by silicate as well. There's local high base metals like copper, so the copper then would compete with gold in the recovery circuit and impede the gold recovery. And then finally, there's a whole lot of carbonaceous material that also tended to cling to the gold through the recovery process and impede that effort to get the gold released from its rock matrix. So it stood fallow for many years. We'll also look quickly at the Bayaguana district. I'm not going to talk in detail about Pueblo Viejo today because that I'm saving for tomorrow. But the Bayaguana district was formed at about the same time and in the same geologic setting. So here's our Pueblo Viejo district. The Bayaguana district is actually much larger, and we have the same series of rock units. The basaltic andesites in green, in pink, volcanic dome field of dacitic or rhyodicitic composition, but still tholiitic. And then a basin filled with sediments and overlain by this Hatillo limestone. This has been an active exploration area for many years. There are a couple of small resources been defined so far here at Cerro Kiosco, also at Doña Amanda, but nothing to compare with the big Pueblo Viejo discovery, which, if it's like its close cousin, will be found in this sedimentary basin over here. In the late Cretaceous, that intraoceanic island arc evolves in composition from tholeiitic to calc-alkaline. And we get then a change in the type of mineralization that's associated. So going back to our tectonostratigraphy, now I've got, let's call it my third big rock unit package, the island arcs. And I'm painting now everything that's an island arc volcanic rock, distinguishing the tholeiitic island arc compositions from the calc-alkaline island arc. They all may be part of a single arc, but in terms of our metallogenic evolution, it's important, I think, to distinguish our tholeiitic from our calc-alkaline rocks, just because they have such a strong influence on the type of deposits that we find associated. Once we're into that calc-alkaline rock, we're getting porphyry, copper, moly deposits and lots of epithermal mineral occurrences all over the place. So these two porphyry deposits and the epithermal suites, the low sulfidation deposits they're often called, are typical of that calc-alkaline period of tectonic evolution. And example here is the Douvrai deposit in Haiti. The schematic diagrams that you're all familiar with for porphyry coppers and epithermal gold silver deposits. Some shots of the mineralization at Douvrai. 190 million tons at 0.3% copper, not in production. Just a little too small, little too low grade to make it economic at this point. And also some shots of the Jacinto deposit in the Camagüey district of Cuba. Again, it's a pretty small deposit, just 1 million tons at a little under 5 grams per ton. Vein hosted, not in production. Then in the late Cretaceous, that island arc that we've been describing, its evolution from tholeiitic to calc-alkaline, it begins to collide with the margin of North America. So here's the Antilles arc, and it collides with a prominent portion of the Gulf of Mexico, maybe an early version of what the Bahamas are considered today, which is stretched continental crust. So there we then have the opportunity to create orogenic or collision-related deposits, of which we have a few examples in Cuba, Descanso, Melonera, a few over here in the Holguin province. The main one is Delita on Isla de Juventud. And then there you have our politic and graphitic schists that are hosting these, let's call them metamorphic sweat veins, typical orogenic kind of deposit, something that's where the mineralization is clearly related to the process of metamorphic dewatering. Estimated 19 million tons at close to 3 grams per ton gold, not in production. So finally we end where we began with this metallogenic map. We've gone through the metallogenic evolution, beginning with the separation of North and South America, the development of rift basins, and the formation of SEDEX deposits. Moving on to the initiation of island arc volcanism, which perhaps was occurring way off in the Pacific, and the development of volcanogenic massive sulfide deposits. A period of extension and rifting across that tholeiitic volcanic arc still in the early Cretaceous, 108 to 118 million years in there, and the development of this giant Pueblo Viejo district. The change from tholeiitic to calc-alkaline volcanism at the end of the Cretaceous, and the onset of porphyry copper and epithermal gold silver deposits. the collision of that volcanic arc with the margin of North America and the development of orogenic gold deposits. As a result of that collision, the uplift of those fragments of oceanic lithosphere, exposing ultramafic rocks at the surface, their weathering then beginning in the early tertiary developed these famous nickel laterite deposits. And then finally, we really haven't talked much at all about the bauxite deposits, which are the most important economically, but they're also presumably developed by weathering, particularly of volcanic intervals interbedded with the limestone sections in those countries. And there's a picture of one of the bauxite deposits from the Dominican Republic. Okay. And that's just this list of the same events we talked about. So that, in a nutshell, if you will, is the tectonic and metallogenic evolution of the Greater Antilles. And I'm looking forward to discussing the same topic, the same features here with you folks today for Mexico. Thanks very much.
Questions? Anyone?
Yes.
Yes, okay. Very interesting. I'm more like a biologist girl, so this is a little bit new for me. But I was wondering if there are this kind of sulfur deposits or here in Mexico, because for me they are very exciting for microbiologists, for this interaction between metals and sulfur, and then suddenly to see them exposed to the surface with a very different biochemistry, for example. But I don't know if in Mexico there's a possibility that this sulfur deposits exist or not. I know.
Well, I don't think I should be the one to answer that question.
Oh, sorry.
Yes, because I'm just beginning here in Mexico.
Okay.
Would someone like to answer? Take that on.
Well, we could talk about that for hours, but we could.
Okay, well.
Yes, there are many of these. The metallogenic history of Mexico is not very different from what Carl has been telling us. However, the scale of the processes and there are some particular aspects in the tectonomagmatic evolution and metallurgy of the two regions that are particular. In this case, we're speaking about a small region, a relatively small region, not that small, but in comparison with the Mexican Alps, we're talking about a small region, but with basically the same stages of evolution, all condensed into a small area, whereas in Mexico we have all that at a huge scale, at the scale we would expect from a continental margin as well. So we have quite a lot of this with some specific differences.
Yeah. You're interested in the kind of the link between biology and sulfur and metals.
Yeah, microorganisms.
Because there are lots of there are engineering applications too. A lot of our Pueblo Viejo is an example where biogenic processes are being used in the treatment of the ores, and it's been an area of research. I know when I started my career, there was no anything biogenic was considered an impediment to the process, and now we're using the bacteria to help with that oxidation process to oxidize the pyrite that's encapsulating the gold and release it to the solutions using copper as well.
Exactly, that's exciting though, to use biofluids and bioprecipitation to recover metals, for example, from very low quantities of materials. So
Yes, yeah, that's an exciting field, I think. Yeah, you'll have lots to do.
yeah. Well, thanks very much.
Thank you. Sure.
I have a question. What do you think about the origin of the epithermal deposits in the late Cretaceous? If they were more like, I was wondering if the previous rifting or extension period from 110, 118 million years could have favored the next stage of epithermal porphyries to emplace in the late Cretaceous. I'm going to I think that there are two things that could have favored the epithermal porphyries. Maybe the change from tholeiitic to calc-alkaline volcanics, and the previous extension that would have favored the conducts or the ways for the fluids to ascend, or what do you think about it?
Well, Pueblo Viejo itself, which is that big monster of a deposit with 30 million ounces, and it's in the early Cretaceous during that rifting episode you just mentioned. That's certainly been called an epithermal deposit. And there are good reasons to call it epithermal. There's sulfidic silicification, there's a bit of alunite, high-grade feeders, a lot of that funnel-shaped alteration geometry that you remember from Buchanan's model from the 1980s. So there's a good argument can be made that the Pueblo Viejo itself is epithermal in origin. But just empirically, most of the occurrences, not the big ore bodies, but most of the occurrences seem to be related to the calc-alkaline rather than the tholeiitic period, and seem to cluster, if you will, around the porphyries, or the porphyries, shall we say, emerge from the epithermal clusters. That's particularly true of Colombia as well. I brought a metallogenic map I've been working on for Colombia, and that's been fascinating to watch. If you just plot all the epithermal or all the vein occurrences of gold and silver in Colombia, all of these new porphyries have been popping out from those clusters, where that galaxy of epithermal and vein type precious metal occurrences clusters together. That's where the porphyries have been emerging. I'd be happy to pull that map out and show it to you. I'm crazy about maps. I'd rather because they really do reflect our understanding of what's going on. I think there's nothing like trying to put a map together to figure out where you're confident and then where you're not so sure.
Thank you.
You're welcome.
Anyone else? Aunque sea en español.
We'll continue tomorrow with a more detailed look at Pueblo Viejo. That'll be fun. Thank you.
Well, thank you. It's intriguing, a little bit intriguing by comparison, at least. The way the magmatic and orogenic processes end up in the Caribbean region, which is which well they end up with collision, and that's the end of it. From organic gold deposits you get only to laterites and bauxites and so on. So those who are familiar with the metallurgy of Mexico, you can establish some particularly interesting differences between the metallurgy of the Caribbean and the metallurgy of Mexico, which still continues, because we still have an active arc, and not the Caribbean. That's all quenched by that collision, and that's the end of it. Yes?
Right, that metallogenic evolution of the northern margin of the Caribbean pretty much shut down in that latest Cretaceous, early tertiary collision. Since then, it's all been strike-slip motion as the continents of North and South America continue to push west, and about all we've had going on is weathering. No active volcanism on that map.
So if you start from knowing a little about the metallurgy of Mexico, which you should be familiar with right now, you can, by comparison, drawing very interesting ideas from this talk or the paper from this talk stems or takes after. Then with knowing a little about the two areas, you may think about other possibilities for the two areas, for both areas, or any other areas. You are familiar with the metallurgy of the Andes, which is more similar to Mexico's, but it also has interesting differences, and it's all related within the same region. So you could benefit from reading into it, and you should take into consideration that Geología ACA paper, which is 2011. 2011. So it's highly recommended that you would read that paper, which is all what we've been seeing today.
Yeah, I'm looking forward to discussing with you what of the approach I've taken might work here in Mexico, which of these tectonostratigraphic units we can just use, and what additional things would need to be added. The metallogenic endowment of Mexico is orders of magnitude beyond what we have on that map there. So it's a much bigger project, but much more information to work with too.
So that goes for you to draw ideas from it, because all the lithospheric rocks we're dealing with here are huge in comparison with what they have up in Till. So you should be able to be very clear identifying which pieces of lithosphere tell us something about the further organization of the metallurgical framework in Mexico. So we all need to learn a lot about this approach they have, because their problem there was simpler. Then if we all need to make things simple in order to gain some understanding of how things work at a huge scale as we're doing here. So don't be afraid. You just need to work. Well, thank you very much. It's been huge, like interesting. You have some questions? No. Only yawning. Well, thanks so much for this extremely illustrating talk. And Carl also brought the actual metallogenic map of the Greater Antilles, which is a huge sheet on the floor. So you are very much invited to pass to learn something about it. And as ever, we also have okay. just to put some practical stuff for you. Thanks so much. And there's another comment for tomorrow. Ahora ya me importa, le pueden preguntar cosas. Que no los oigan los demás.
Bien, bueno, estamos
Ya apagó la. Apagó.
es mucho mayor.
Pues sí. Hoy tienen hoy es martes.
Bueno, ¿ustedes qué son? Martes.
Bueno,
Con el celular. Sí. Dice que para esta tarde que a todos
I was looking to see if they could turn these lights on so that folks could look at the map.
¿Puedo desconectar? ¿Cuál es?
Es el dimmer aquí.
Cero. Cero. ¿Lo desconecto ya?
Sí, sí, sí quiero.